Good morning, mathematicians. How's it going? Well, you can't answer me yet because I haven't opened up chat. So I'll have to sit here in suspense until my live stream shows up. How's it going? As the title suggests, it's not dumb. It might seem dumb, but I have my reasons for solving this problem. And I will explain them. Actually, no, I won't explain my reasons. But what I will do is explain the problem. Wow, the stream from 2 days ago really popped off. I put a thumbnail now, because the stream from a couple days ago had I think that was right after my Wild Burger video, which had something to do with it, but also the thumbnail that YouTube chose. I had my head like this, and I was talking about my new paper, and but it wasn't even my paper. There was some other paper on screen that said chapter 1. Yeah. So I think I understand why that one did good in the algorithm. There's several reasons. But hello, Castaka Corey. So here's this possibly hello Lockheed Clippy Bird. Possibly silly question. I have. You were interrupted setting up Doom Emacs by live stream. Well, I believe in your ability to multitask. So what is it? I have two matrices. I have two 4x4 matrices, quite sparsely populated. I don't know what X, Y, and Z are. I do know they're non-zero, and in fact, more specifically, I know they're 2 to the nth roots of unity. Man, this is crazy. My memory is so bad. You said WSG gang the other day in chat, and I was like, what does that mean? And then you explained it, and now I don't remember. That's concerning. That's concerning. Well, I appreciate you stopping by anyway, Lockheed. And then I've got a second matrix. 0, 0, 1, 0, 0, 0, 0, alpha, beta, 0, 0, 0, 0, gamma, 0, 0. Oh, what's good, gang? Okay. There's some sort of joke there about me asking WSG and what's good, gang, like some sort of what's up, dog type joke. I feel like there's something that could be done there. I haven't had enough coffee yet to hash it out. Yeah, okay, so I've got these two 2x2 matrices, and I know for abstract reasons that we don't need to get into. So do I know? What are the important things? X, Y, Z, alpha, beta, gamma. These are all non-zero. And I don't think it matters, but they are all roots of... they are all... No. They're all 2 to the nth roots of unity in the complex numbers. You have a linear algebra exam coming up next week. Maybe this is a good problem to try. Maybe, but to be honest, well, I don't know. Maybe it is good. Maybe it is good. I don't know if this problem will result in you practicing your linear algebra skills. Although I do have a good, if you're doing eigenvalues and eigenvectors, then I would challenge you to compute the eigenvectors of these matrices in terms of their entries. And so here's what I know. I know that for abstract reasons, I know that there exists a subspace where it's two-dimensional. In fact, there's two subspaces. There's two such subspaces. Maybe I have an idea. Okay, I'll tell you in a second. So this subspace has to be two-dimensional. And what else? It is going to be preserved by both x and y. Is going to be preserved both by x and y. Fun fact, one obscure NLab page plus one obscure art and paper seem to suggest an analogy between CSAs for Azumaya algebras and continuous trace C-star algebras. Huh. CSAs look a tal locally like matrix algebras, so it makes sense, but you can't find any actual discussion. Maybe you're right. Maybe this is maybe this is our project. Maybe this is it. We first internet YouTube live stream collaboration. We prove something about the analogy between CSAs and continuous trace C-star algebras. I feel like I need to go read about continuous trace C-star algebras first. Eigenvalues and eigenvalues, I suppose you meant one of those to be eigenvectors, have traumatized you because of Indian uni symbols for linear algebra sucks? What do you mean by that? Like in India, you don't like the notation they use? What do you mean? Linear algebra is just taught to us as a black box matrix calculations machine rather than something actually geometric. Yeah, I guess that happens here too to some extent, although there's some focus on algebra. What's the T on C-star algebras? You hear a lot about them. Syllabus. I see. What is the T on C-star algebras? Let's go look at I mean, they're all over functional analysis, but let's just look at that. Well, it's a Banach algebra. There you go. Together with an involution, which is like an adjoint. An important class of non-Hilbert C-star algebras are complex valued continuous functions on X that vanish at infinity for a locally compact Hausdorff space. There we go. Quantum mechanics. Boom, boom. Apparently K-theory of C-star algebras has something to do with it. Yes. All right. Take care, Lockheed. Thanks for joining us. You mean they're supposed to be non-commutative spaces due to Gelfand duality? I'm vaguely aware of this idea. C-star algebras are used in formulation of algebraic quantum field theory. That makes sense. Am I doing any research? I am doing research. Well, I just published. I just put a preprint on Archive like 2 days ago. But I've got another project on the go, and actually, secretly, not so secretly, this algebra question I have is actually like one small piece of another thing I'm working on that's not like my thesis research, but it's something else I've been talking about with a friend. And basically, there's this one thing I'm interested in. Well, one small part of this I've reduced to this linear algebra problem. But those of you in the know, Nerdy Quigs, how you failed your computer science exam? Are you serious? Oh man, that's not good. Maybe we should stop having our meetings until you get your grades up. If that's for real. Because I don't want yeah, that's no bueno. You just pre-printed all over the place yesterday. Train or bus is just general question, Boris. If I prefer the train or bus. In general, and very broadly speaking. I prefer taking the train here in the city as opposed to having to take buses if I can take the train somewhere, if I'm in such a location. But, you know, my father was a bus driver for many years. So, you know, I've got a, oh, I missed the pun. Yeah. Yeah, I missed the train on that joke. Do I have suggestions for learning? Oh, does Paul Maurice have suggestions? Yes, because I don't have suggestions for QFT. How many years left till I get the PhD, or do I have to finish the research? Well, research is never finished. I think I've done enough for a PhD now. I just need to staple my papers together. So I'll probably do that in the spring. The exam was 2 questions, one worth 20 points, one worth 10. And you're pretty sure you got basically full marks for the 20 mark one. Okay. So that's not failing. That is not doing good. If you only got 2 out of 10, but good morning, Mom. Good morning, Mom. Mom has entered the chat. Thanks for joining us. And how do you know about QFT if not for the physics? You know, Atiyah defines it as a functor between n-cob. What is n-cob? And Hilbert spaces, but that makes no sense without physics. There are 2 volumes by Deline, Witten et al. At Quantum Fields and String, a course for mathematicians. Huh. Okay, so here's this idea I have for this problem, and this might give away to some of you what it is I'm thinking about. But there is actually a way to put an inner product on the space. And how should I describe it? How should I describe it? It's not a big deal if I give away where this linear algebra problem comes from. But okay. I know that there is, maybe I'll just do this on my own later. I know that there is a way to put an inner product on this space where uh, basically I'll be able to find two subspaces that are orthogonal to each other. So this is, yeah, how do I notate an orthogonal direct sum? But basically where C4 will be an orthogonal direct sum, and then both of these spaces will be preserved by X and Y. Lebesgue integrals were also ill-defined before Lebesgue was born? Huh? What? I've never heard this. You've been told it's cutting-edge mathematics waiting to be formalized. I mean, people have been talking about the ill-formedness of QFT for quite some time. So, yeah, maybe the world's just weird. The math of the world is too weird to formalize. Some months ago, you encountered a paper on detecting torsion in TMF. What's that? What's TMF? Using QFTs. You think there's applications to quantum knot invariance? TQFT is a physically twisted version of QFT Yang-Mills. By taking any diagonal SU2 of SU2. Is that just the ordinary product, or what is that? Diagonal? What's that star? You guys are losing me in chat here. Oh, topological modular forms. Okay. But now, actually, okay, I need to think for a second about this pairing. Because yeah, if I think about it, good question, Boris. I mean, people also, I mean, I'm sure, this is all legitimately tied to quantum, but there's also a lot of stuff in math that like is loosely connected to quantum mechanics, and then we toss like quantum in front of it. Like, I think there's a bunch of stuff like quantum groups, like how closely to how closely related to quantum mechanics are quantum groups, really? I don't think that much, to be honest. Nerdy Quagsire, what do you mean 16-minute stream? I haven't ended it. I'm not ending it yet. I'll be ending it soon. I hope I didn't. I hope I haven't frozen or disappeared or something. This won't be a long stream, but yeah. Okay, wait a second. Now I got to think. If we sum up all the roots of unity, that's 0, right? Right? Am I crazy? Yes. Well, maybe that's why you got 2 out of 10 on your computer science question. Boom. Bro got cucked. Let's see. I mean, we factor, right? We do our usual trick. We factor this out. This is, yeah, Cn minus 1 plus Cn minus 2 plus C. And it will be, and that burn will be immortalized on the internet forever, because my channel will never die, like me. Yeah. Whew. May the burn May the burn fuel your passion for learning. That's what I say. Okay, am I out of my mind? Yeah, this says this should be right, right? Like the fourth roots of unity. This is a basic fact about roots of unity, right? Yes, of course. Of course they cancel out. Okay. So, let A be a 2x2 matrix of finite order over Z. Show that A to the 12 is 1? Huh. Show that A to the 12 is 1. So, A, with what coefficients? 2x2, what field? For n sufficiently large, and we want to show that A to the 12, am I reading that right? A to the 12 is the identity? Oh, right, sorry, you said coefficients in C. Yeah. Interesting. You found my channel by doing some research about K-theory. Oh, nice. I mean, the funny thing is, the sort of joke is that my channel, I haven't made any videos on K-theory in the 4 or 5 years this channel's existed. Hello, Fimno. But I might at some point. It's just my name starts with a K, and so does K-theory, and it's a math thing. So I thought it'd be a good name for my math channel. One of these days, I've got this book. I've got this book from Karubi. Perhaps one day, in the near, not too distant future, I will start making some videos based off this book. But yeah, that's an empty threat, Arad. We all know it. I should really teach some K-theory for my channel's namesake. Yes, you're right. And yes, Growth and Deke would be disappointed. A cardboard cutout of Quillen behind me. Yeah. Or I wonder, yeah, okay, that would be good. I wonder how much a cardboard cutout of Quillen would cost me. I'll look into that maybe. Gotta get on selling some merch. Oh, I did also tell you I might start a channel about a series about representation theory. Actually, I was thinking about that as well. That is more likely to happen sooner than K-theory, just because representation theory is something I can, at least for early videos, make a bunch of them just off the cuff, off the dome. And I don't need to prepare a lot for some basic representation theory. Whereas Karubi's book, in order to do things right and rigorously, it would take me a little time. I'd want to make a script and stuff. So, goated, painfully French though. Yeah, that's true, Arad. Yeah, I wonder. Yeah, I could maybe at least set it up. I could maybe set it up to get Quillen's face here in the meantime. Just popped up looking over me. I've never used a Quillen determinant. You'd never watch my representation theory videos? Yeah, I can tell by the way you don't do your homework between our meeting sessions. Boom, burned again, Nerdy Quagsire. Double burn on the stream. I like bugging you. But I hope we're still friends. Just kidding. I want you to be my we're not friends. You're my representation theory minion. Here to do my dirty work about induced representations. Okay. Let's think about this problem for 2 seconds before I end stream. So we're looking at matrices which okay. They're equal to 0 for some sufficiently large power. Well, we should know something then about their eigenvalues, right? Right? What does that mean? Doesn't that mean their eigenvalues are 0? Doesn't that mean their eigenvalues are 0? Let me take a look here. Right? Matrix is nilpotent if eigenvalues all 0. Nice. Okay. So, so what can we do with that information? I mean, nilpotent means strictly upper triangularizable. Interesting. Yeah. So, but I think there might be something with the characteristic polynomial, like if somehow we try to work this out and think about what would be required. True pajama man, it's only true over fields, but what we can do is like think about these general conditions about like over the field, and then later, like, I mean, it is still true because yeah, Z is oh right. I mean, it is a domain, so it's a PID even. So some results should lift, but even so, we can take these things that we know are true of complex matrices, and then still maybe finagle some things like adding the conditions that we know that our coefficients are integers, and maybe we get something out of it, right? So why did your name change? Oh, it's Thomas. Oh, I have no idea why your name changed. So if I haven't done my math wrong, this is lambda squared minus a lambda minus d lambda plus ad minus bc. Oh, that's interesting. We got the determinant out there. I guess we always get the determinant out there. Wait, what? Prove that you're Thomas. Yeah, we need some cryptographic signature scheme here. Everyone drop your favorite cryptographic signature scheme in the comments. Did I do this right? I think I did. Shouldn't the determinant should be the product of the switch off Neary, Brian? The X11 support is so bad, huh? Let me think. That was I see. That was Thomas verifying to Brian. Yeah. Right. I mean, the determinant, we also know that the determinant should be the product of the eigenvalues. So we know that the determinant is 0. Although I guess that's not surprising. We already knew that from this equation. So that's one part of what we need to solve. So we know that we have an integer equation like this that we're trying to solve. But also, let's see. So all of the eigenvalues should be 0. So if we use a quadratic formula, minus b plus or minus the square root of b squared minus 4a times the determinant. So maybe I'll call this gamma for the determinant for just a moment. Chat shows things now. This shows the torsion subgroup of has exponent. The torsion subgroup of what? Equivalently very finite order integer matrices has order dividing. I think some words are missing there. Number twins. Yeah, so I mean, this gives us another equation, right? So I mean, we know that this should be 0. We know that this thing has to be an integer. So a plus d root of a squared plus 2ad plus d squared minus, I don't know why I changed it for like one thing, minus 4ad minus 4bc. Okay, this probably isn't the right approach. This probably isn't the right approach. Well, we know, hang on, but we know now that simultaneously this will only be 0. So we need two equations. We need a d plus this root should be 0, and a plus d minus this root should be 0, right? So that tells us that, for example, a plus d is equal to 0. So we know that d is minus a. Oh, Kaylee Hamilton. Yeah, that's true too. That's true too. Oh, I see. I see. Yeah, maybe we should just apply Kaylee Hamilton. Although, yeah, maybe. Actually, I'm not so sure. I probably need to go. Actually, let me check. Probably should have looked at my calendar first when I first woke up to figure out if I had to be anywhere for any specific time. I don't think I do. I mean, I do have like applications that are due soon. Yeah, I don't have to be anywhere. Okay, so I've got d is minus a. What else has to be true? Well, if we subtract both of these things, we also know that the square root has to be 0. So, in fact, this whole thing has to be 0. That's not very helpful because this is nasty. This is a nasty little guy over here. Hello, Zhang Ribayev. Good morning. Or good afternoon or evening, depending where you might be. Well, actually, okay, hang on a second. If we know that d is minus a, maybe that simplifies some things here. So then this is a squared plus or minus 2a squared plus a squared. So these terms all cancel out. Minus 4, or sorry, now it's plus a squared minus 4bc. So this means that we know that a squared minus bc has to be equal to 0. So a squared is b times c. So, okay. How does that help us? So we know we have a, b, c minus a. I wonder what happens when we square this now that we have some of these relations, because we get something like a squared plus bc ab minus ab, so that's 0. AC minus AC, so that's 0. And this becomes a squared. And we know now that a squared is BC, so this is 2a squared. Wait a second, I must have made a mistake, because how is this going to have order 12? Because now it's diagonal. We must have made a mistake somewhere. Well, what better time to end stream than when we know we're completely wrong? And when we figured out we made a terrible mistake somewhere. At least I know what I need to do for my problem that I'm going to do on the bus ride to campus right away. As for your problem, now that I've almost certainly led you completely astray, Thomas, it was a good time to peace out. Yeah, I don't know. Maybe try Kaylee Hamilton. I mean, yeah, that'll tell you no car. Yes, I do choose trains, but unfortunately I'm not located near the train station. It is not convenient for me to take a train. The only problem I was thinking with Kaylee Hamilton is like, so, you know, you should, I mean, either it satisfies its linear polynomial, makes it 0, or never trust a PhD student with linear algebra. Yeah. Actually, okay, I guess there is one other thing. Maybe we do need to make more use of this statement. Maybe there's more to be said about this statement, right? The determinant is the product of eigenvalues. The determinant is the product of eigenvalues. Wait, no, we already know that we've already used the fact that the individual eigenvalues have to be 0. I think the finite order is what allows you to use Kaylee Hamilton. Right, because it's polynomial. Well, it's right. It's minimal polynomial has to, if this holds, then its minimal polynomial has to divide it. But I'm not so sure that helps us, right? Well, oh, hang on a second. I know I said I was about to go, but because we know that this should be its polynomial. But I get we just went in circles because we already knew these facts, right? I mean, uh, this tells us that minus a minus d is 0, but we already knew that. That tells us that d is minus a. That's what I learned doing that's what we already learned from doing this by hand, and it also tells us that AD is BC, which is that a squared is minus BC. Okay. That's maybe where I made a mistake here. A squared is minus BC, so this should be 0. There's still something wrong here. BC. Oh no. Right. This is BC. Here we go. Boom. Okay, but then, what? What? But then we showed that this is order 2? That ain't right. That ain't right. I don't think that's right. That boy ain't right. Okay, now I'm going to go for real. Now that I've extra gotten it wrong. This is all part of my pedagogical technique, you see. I'm just taking you through a deep, dark forest to confuse you intentionally as a pedagogical method to make you dig your way out. Yes, that's just my genius as an educator at play. Okay, I'll see you guys tomorrow, most probably, and